Solving equations. When we want to solve an equation, the goal is always to isolate the variable. Isolate the variable. We want to get the variable all by itself. Isolate. This is the Tuesday paper on how Tuesday paper. Everybody should be taking notes on here. Okay, we want to isolate the variable. So in that example you did at the beginning of class, no, top, arriba. Yep. 2x plus 6 equals 14. So my goal when I'm solving the equation is to isolate the variable, get the variable all by itself. What is my variable in this equation? What was my variable? Uh-oh. Huh? X, right? Variable is just the letter, right? So it's x. We want to get the x by itself. What is like preventing the x from being by itself? What's over on this side of the equal sign with that x? 2 and plus. And that plus 6, right? Perfect. So I need to get rid of the plus 6 and I need to get rid of the 2. But how do I know what to get rid of first? How do we know what to get rid of first?
Well, first to get the 2x by itself, you would want to start with the number that's next to the sign, you would want to start with the 6x because the plus sign is next to it.
Yeah, that's good. So we talked before about we need to move the term away first, and then we move the factor, right? We've talked about that. We've also talked about undoing the operations that we see by going backwards through the order of operations. Let's talk about that. What's the order of operations? When you hear order of operations, what do you think of? PEMDAS, right? P-E-M-D-A-S. When we want to evaluate something, we move through order of operations, right? Parentheses and then exponents, multiplication, division, addition, subtraction. When we're solving equations, we have to go backwards. And I think about it like socks and shoes. When you put them on in the morning, you have to do socks first and then shoes, right? No one's wearing their socks over their shoes. At least not that I know of. You know, I think there's like anyway. But then when you take them off, you have to go backwards, don't you? You don't take your socks off and then your shoes. You have to go the opposite way. Take your shoes and then your socks. So it's the same thing when we're solving equations. We have to go backwards through order of operations. So let's look at this. So I've got 2x plus 6 equals 14. What are the original operations that we see in this equation? What are the, good, there's addition, right? Plus 6. What else is there? Multiplication. There's division. I don't see any division in here. So what are the original operations we see in this equation? Where is the multiplication? Because I don't see any multiplication sign. Very good. 2x means 2 times x. So that means I have multiplication and I have addition. If I was following PEMDAS, I would do the multiplication and then the addition, right? But when we solve, we go backwards. What's the opposite of addition? And the opposite of multiplication? Okay. So I'm going to first undo adding 6. I undo adding 6 by subtracting 6. And what does it say over there? It says algebra's golden rule. What does it say underneath it? Exactly. So if I subtract 6 over here, I also must subtract 6 there. Not subtract 6 from the 2. I see that all the time. Both sides of the equals sign. Okay. So what happens here? I have a positive 6 minus 6. What happens? It cancels out, right? So now we just have 2x equals 14 minus 6. Good, 8. Okay, so I undid my addition with subtraction. Now we need to undo this multiplication by dividing. So I undo times 2 by dividing by 2. So my 2's here, I've got 2 over 2, that's just 1. So I have 1x, or just x, equals 8 over 2 is 4. Perfect. Okay. So in order to get the variable all by itself, we have to undo the operations that we see by using the inverse operation. Inverse is, in this case, just means opposite. And we can always check our answer by plugging it back into the original equation. So my original equation said 2x plus 6 equals 14. If I want to check to make sure I'm right, I'm going to take the 4 and I'm going to plug it in for x. So I get 2 times 4 plus 6 equals 14. What's 2 times 4? 8. Is 8 plus 6 14? Yes, it is. So I know that I'm right. I don't have to ask if I'm right. I know I'm right because I just checked myself. So you always have that option. Okay, so we've kind of already said this. Inverse of addition is? What's the opposite of addition? Subtraction. So that means that the opposite of subtraction is? Opposite of multiplication.
Division.
And therefore the opposite of division. Good. Great. All right, so this problem that we did for Bellworth, that's a two-step equation, right? I had to undo the addition and then undo the multiplication. These problems down here on this part, they're all one-step equations, just one step. And we'll kind of just go through these really quick together. So let's look at number 1. What operation do you see in that equation? What is the original operation? Addition. How do you undo addition? So I need to subtract what from both sides? Good, the 3. Because that's going to help me get the x by itself, right? So 3 minus 3, that's 0. Got x equals 12 minus 3. 9. Very good. What about number 2? What operation do you see? How do you undo addition?
Subtraction.
Perfect. Same thing, right? Doesn't matter if it's 3 plus x or x plus 3. Process is the same. Just getting rid of the 3. So I've got x is equal to what in number 2? 7. Perfect. What about number 3? What's the original operation? How do you undo subtraction? So what am I going to add? 4. Good. I'm going to add 4 to both sides. Right? Yeah, these 4's cancel out, so we have x is equal to? Very good, 16. What about number 4? What operation do you see? You see subtraction. So do I need to, so I'm going to add? What am I going to add?
4.
Yeah, but does 4 plus 4 cancel out to 0? But there's subtraction. I thought addition was the opposite of subtraction. Good. So I'm subtracting the variable here, right? Instead of subtracting the number. So that kind of changes it a little bit. And so think about, this is a positive 4. How do I cancel out positive 4? If I have $4, I want to cancel it out, I got to spend $4, right? So I'm going to subtract 4 from both sides. 4 minus 4, that cancels out. And 9 minus 4, that's 5. And then what do I have over here on the left-hand side? Very good, negative x. Is that x isolated? Is the x by itself? No, what's in front of it? Negative 1, right? How do I get rid of that negative 1? Good, divide by what? On both sides. Very good, right? So my negative 1's cancel out. So x equals 5 divided by negative 1? Negative 5. How about number 5? What operation do we see? Good. 6x means 6 times x. So what's the opposite of multiplying by 6? Divide by what? By both sides by 6. So my 6's cancel here. I've got x is equal to 4. Very good. Okay. What about number 6? What operation do we have?
Multiplication.
Yeah, it's still multiplication. I know I've said that before. Fractions are really just division, which is true. But I'm taking 2/3 and I'm multiplying it by x. So we could do the same thing we did before. I could divide both sides by 2/3. But I also taught you a little shortcut with things, with problems like this. Do you remember?
I don't remember. You divide two of the same numbers on that side, and the same number you're dividing with the others on the other side.
Maybe.
I'm not really sure how to put it.
Yeah. Good. Yeah. Do you remember what that's called when we flip the fraction? Starts with an R. Good, reciprocal. Reciprocal. So when we have a coefficient that is a fraction, we can get rid of that fraction by multiplying by the reciprocal. Because if I multiply 3/2 by 2/3, I've got a 3 up here, 3 down here, those cancel out to be 1. 2 down here, 2 up there, those cancel out to be 1. They cancel each other out, so I've got the x by itself. But again, if I multiply this side by 3/2, I got to multiply this side by 3/2. And let's turn that 12, we'll turn it into a fraction, right, by sticking a 1 underneath it. How do I multiply two fractions together? What do we need to do? Go straight across. What's 12 times 3? And 1 times 2? So now my answer is 36 over 2. That's just a division problem, right? 36 divided by 2 is? Good, 18. Cool? Any questions so far? Okay. All right. Number 7, what's the original operation we see? Division, right? I'm dividing x by what? So how do I undo dividing by 9? Multiply by 9 on both sides. My 9's cancel here. I've got x is equal to 14 times 9. You guys don't have calculators. Can we do this in our head? Anybody? So 14 times 9 is like 10 times 9 plus 4 times 9. Very good. Yeah. So 10 times 9 is?
90. 136.
Close. 4 times 9 is?
36.
What's 90 plus 36? Good. 126. Okay. And then what about 8? What are we going to do in 8? What's the original operation?
It's the same thing that we did on number 4.
On number 4?
No, like it's
Number 8?
that would have to be the multiplication.
Multiply by what though? Multiply by 36. Well, that would be 36 times 36 over x.
Do you multiply
That's
by
not
1?
multiply by 1. Well, that doesn't change anything, huh?
Yeah.
But good guesses. How do we write 4 as a fraction?
4 over 1.
What if we wrote it like this instead? 36 over x equals 4 over 1. Do you remember how to solve something like that? Yes, cross multiply. Remember that?
9.
Good. 36 times 1 is 36. X times 4 is 4x. And then, Will, what did you do to get to 9?
I looked at the two numbers on top. 4 or 9 times 4 is 36. So just
If I write it out like this, what do we do next?
Divide by 4.
Divide by 4. Very good. Okay? All right. Let's flip over to the other side. Oh, actually, I'm sorry. Same side for you. Different side for me. Let's look at these. So more two-step equations. So again, we undo the order of operations by working backwards. Okay, so first we need to identify what are the operations that we see in the original equation, and then think about how we undo those. So let's start with number 10. Number 10 is just like the one we did for bell work. What are the two operations we see in number 10? Good, multiplication and addition, right? Multiplication comes first in PEMDAS and then addition. So then that means I need to undo what first? Yeah, we need to subtract to undo the addition first. And then what do we do to undo the multiplication? Divide. Cool? So I'm going to undo adding 10 by subtracting 10 from both sides. Right? Think about both sides of the equal sign. My 10s cancel out. I've got 7x equals 24 minus 10. 14. And then how do I get rid of this 7? Divide by 7 on both sides. So x is 2. Perfect. Cool. What about number 11? What are the two operations we have? Very good. Division and addition. So really similar to the last one, right? The division would come first and then the addition. So then we have to undo the addition first by subtracting and then undo the division by multiplying, right? So what do I need to subtract in number 11? What do I subtract? Got 4, right? Plus 4, so the opposite would be minus 4. Minus 4. 4's cancel out. And we've got x over 3 equals 20 minus 4. Very good. 16. Okay, now I undo the division by multiplying. So what do I need to multiply by?
3.
Good, 3. Right? These 3's cancel, so I've got x by itself. And then what's 16 times 3? Very good, 48. You can use that same trick, right? 10 times 3 plus 6 times 3. 10 times 3 is 30. 6 times 3 is 18. It's 48. All right, very good. Number 11. What about number 9? What are the operations we see in number 9? Huh? Multiplication, right? There's that 2 out in front, and we're multiplying there. So multiplication and there's addition, but what is the addition inside of? The parentheses, right? So what comes first? Parentheses or multiplication? What comes first in PEMDAS? The parentheses always are first, right? So that means that I have to undo the multiplication, right? Undo the multiplication first. So I'm going to undo the multiplication by dividing both sides by 2. 2's cancel out. And we've got 3 plus x equals, what's 12 divided by 2? 6. Okay, and now I just have what's left in my parentheses, right? And it was addition inside of my parentheses, so that means that I need to subtract, right, in order to get rid of the addition. So how do I get rid of this 3? What am I going to do? How do I get rid of the subtract by 3? So x equals 6 minus 3? 3. You have questions on that one? Is there another way we could solve this? Yeah, what do you do?
By looking at it, like it's a pretty simple equation. Got 12, add 3.
Good, you can distribute first if you want to. 2 times 3 would give us 2 times x would give us, right? And now I have multiplication and addition, so I undo the addition, and then I undo the multiplication, and I get the same answer. So either way works. Either way works just fine. All right, we saw one like number 14, seen one like 15, seen one like 16. Let's look at 12. Let's look at 12. What are the 2 operations going on in 12? Oh no, we looked at one like 12. Let's look at, what's one that we haven't, what's one that's different? Yeah, let's look at 13. What are the 2 operations in 13?
Addition.
Good, there's addition and division. Well, this one, number 11, had division and addition as well, right? Does number 11 look the same as number 13? What's different about them? Yeah, up here, I'm only dividing the x by 3. But down here, I'm dividing 9 plus x. I'm dividing a sum by a number, right? So let's just think about this. If I said that 16 plus 8 over 4, what would you do first? The 16 plus 8, right? You wouldn't do 16 divided by 4 and then 8 divided by 4, right? We would do the sum first. So when we see a problem like this, it's almost like there's invisible parentheses around the numerator there. Okay, so I do this first, right? 16 plus 8 is 24, divided by 4 is 6. So same thing here. I do have addition, but that addition is inside of invisible parentheses. So we need to actually undo the division first. How do I undo division? Multiply. So what do I need to multiply both sides by? By that 4. Very good. By 4 by 4. 4's cancel out. We've got 9 plus x equals what? That's 5 times 4. Okay, and now how am I going to undo this addition? How am I going to undo this addition? Subtract what? Good. Subtract 9, subtract 9. So that means that x equals 20 minus 9. Good. All right, I want you guys to just finish this side of the paper. This side of the paper. We went over all the problems at the top up through 18. 19 and 20, we didn't really talk about today, but we have talked about in the past. So give them a try. Reminder that for your grade, right, I grade you every day in class based on the work that you're doing. I can give you a grade anywhere from 0 to 5, right? 0 would be like a totally blank answer. Nothing written down, nothing done at all. A 1, you're at least trying something. Maybe you're not doing it right, but at least you wrote the problem down. At least you tried something. Number 2, you're approaching what I'm expecting you to do, but you're not quite there yet. So maybe, I don't know, like in number 13, maybe you started by dividing by 9. It's like, I know you're kind of sort of on the right track, but not quite there, right? You're approaching my expectations, but not quite there yet. 3, you're almost meeting expectations. You're like very, very close, but not quite there. Number 4, meet expectations. You're meeting my expectations, but you're not really giving me the full answer. Like maybe you just wrote down the answer because you can do it in your head, but you didn't show any work. That's a 4 out of 5, not a 5 out of 5. 5 out of 5 is exceeding expectations. You show everything, show all of your steps, you get everything right. Does that sort of make sense? We'll kind of talk more about that tomorrow. But these are your grades that you're getting every single day. If you're not here, I just mark you as absent. And if you're not feeling well or something, right? Everybody just has bad days sometimes, that's okay. I would give you an exempt for that day. However, I can't give you an exempt every single day. If I start giving you an exempt every day, then we're going to need to call home or talk to counseling or something, right? Okay, I'll come around in a minute and check your work.